So hey guys, in this video let's start with a very interesting question. Coco eating bananas. This is Leetcode number 875 and it's tagged as medium. First let us read the question. So it says that Coco loves to eat bananas. There are n piles of bananas and in each eighth pile has piles of five bananas, and there are, let's say, there are a set of cards, and they've gone out and will come back in headshots. Okay, so at this point we just have an array with n piles of bananas, and each of the ith um, index element represents how many bananas are there. So now Coco can decide her banana eat per hour eating. So basically her speed um, as k, and at each hour she chooses some pile of bananas and eats k bananas from that pile. So in 1 hour she can in every hour she can only pick one pile and eat bananas from it, not from different piles. And if the pile has less than k bananas, she can eat out of she eats all of them, and will not eat any more bananas during that hour. So if her speed is like 5 and the pile has only 3 bananas, then she'll just eat 3 within, let's say, 20 minutes and just keep quiet for the rest of the hour. So she wants to eat slowly but finish all the bananas before the cards return. So finally, our aim is to return the minimum, uh, her minimum eating speed, so that she can finish it within 8 hours or H hours within before the cards return. So first let us check an example, right? So if we have example 3, 6, 7, 11, just taking the example, right, which has been given in lead code, and we're being given that h is equal to 8. So now we have to find k is equal to what? So min of k, so that mm, Coco can finish all the bananas. So here, right, so the output here is given as, it's given as 4. So let's see why it's 4, right? So let's say we have 3, 6, 7, 11, and this is the number of hours that we need for each pile. So each element represents one pile, and if our eating speed k is equal to 4, so there are only 3 bananas, so we can finish in 1 hour. Since there are 6 bananas, right, we basically get 4 in the first hour, and then second in this 2 in the second, so 1 plus 1, that's 2, and result here, so 1, 2, and then here we again can eat 4 plus 3, so that's again 1 plus 1, so now it becomes 2 again, and here as well, right, so we can eat 4 first, and then uh, 4 plus 8 plus 11, so we need 3 hours to finish this pile, so this 1 plus 1 plus 1, that is equal to 3. So now if we add all of this up, right, so 3 plus 2, 5 plus 2, 7 plus 1, 8, this is equal to h is equal to 8 value. So if you think about it carefully, right, so we basically have uh, the number of choices of k. So the number of choices that k has is the max of the array, right, of the piles array. Why do I say this? Because if we have 3, 6, 7, 11, 11, right? Now if k is equal to 11, okay, so we can basically eat this pile in 1 hour, this pile 1 hour, this pile in 1 hour, this pile 1 hour, right? So that's equal to 4, okay, which is less than 8. So this is the maximum boundary that we can have. So that's 11 bananas, and what's the minimum boundary, right? So if you guess right, so it's one. So the minimum number of bananas that you can possibly have is one. So if you have k is equal to one, because it's given in the condition as well, right? So you need to pick at least one pile every hour. So if you pick one pile and eat only one banana from it every hour, so then you end up, uh, you know, with the number of hours being much greater. Like let's see. So here, if you eat only one banana per hour, this would take you one plus one plus one. This similarly, this would take you 6 hours. This would take you seven. This would take you 11 hours. So, I mean, it's 11 plus 7, that's 6 plus 3. No, whatever it is, it's much, much greater than 8, right? So, in this case, k is equal to 1 cannot be our answer, but definitely, right? K is equal to 11 can be an answer as well. Uh, so, okay, now the question is, right? So, we can have, skip k value can be 1, 2, 3, and so on up to 11, right? Yeah. So these are all the choices that we have, as the speed with what you can eat the banana. So one observation we can make here is, let's say, if she can eat the banana in 4 hours, right? If she can finish all of it with an eating speed of 4 bananas per hour, so not 4 hours, she can definitely eat it in 5 hours, five bananas per hour, 6 bananas per hour, seven, and so on, right? So until 11. So there's no question about that. So the only thing we need to find is, if you come to a solution, we can't just stop there. Unlike regular binary search techniques or any other search techniques, we need to kind of filter that part of the array, which in this case is the entire right half, right? Because any of these can be the answer, but we need to find the minimum eating speed. We need to filter the part of the array and then check only this part, which is less than 4, and then check if with this eating speed can we finish all the bananas within 8 hours or not. So, like, you might have understood now that it's like kind of elimination. uh, just put it in words: elimination of possible solutions, right? Okay, so this is uh, something that we're going to do in this problem. This is the main point, or the main agenda of this problem. So always in this type of problem, right, we apply binary search. Okay, this is always true, that you need to eliminate certain possibilities. And yeah, one more thing I forgot to tell you is, we basically choose 11 as the max bound here, because uh, it's the, I mean, maximum number of bananas that Coco can have in 1 hour. So that's that's why we choose 11 as the max bound here. So let's just go through binary search, right? And just let's run it and check if we actually get the answer or not. So 8, 10, 11. Just keep this all copied. Yeah. So now we start our L here, then we start our pointer here. Okay. So now, let's say we have mid. So mid is equal to n plus r, and so divided by 2. So this would be 6, right? So this would be mid. Okay, so it's equal to 6 in this case. So now let us check our uh, 6 11. So let us check our piles array. Piles. Okay, and let us check if we can, if we have a eating speed of 6 hours, can we finish all the bananas or not? So here we can finish this pile in 1 hour, plus this also in 1 hour, plus this will take us 2 hours because 6 plus 1. This will also take us 2 hours. That's 2 plus 2, 4, 5, 6, 6, and it's definitely smaller than 8. So yeah, 6 is an answer, and we can finish all the bananas in 6 hours, right? So basically, if we can finish it in 6 hours, and we can finish it in 7 hours, or 8 hours, 9, 10, and 11, like I explained before, right? So the eating speed increases, we can definitely finish it in lesser time. So, but in this case, right, we know the answer, so I mean, it's 4. It's not a big deal, but we 6 cannot be the answer because we just cannot say that 6 is the answer because they can, if we reduce the eating speed to less than 6, we might also get an answer where the number of hours may be less than 8. So we still need to keep running our binary search in that case. So what we do now is, since this half rate from 6 to 11 is basically eliminated, we move our, our pointer from here to 5. Okay, and our L pointer will remain here. Now our mid would be equal to 3. Now our mid would be equal to 3. So let us find if we can eat the bananas in 3 hours or not. So 3, 6, 7, 11. Sorry, we can. I'm sorry. If we can eat uh, all the bananas with an eating speed of 3 bananas per hour, so this would take us 1 hour. This would take us 2 hours. This will actually take us 3 hours because 3 plus 3 plus 1, right? 3 hours. And this is 3 plus 3 plus 3. This is 3 hours plus 1, so this is 4. And so this will be 10 hours, which is greater than 8. So this cannot be our answer, right? Uh, so so 3 cannot definitely be our answer over here if we eat 3 bananas per hour. So now there's no point of decreasing the eating speed, right? Because if we can't eat all the bananas in, with the speed of 3 bananas per hour, definitely we can't eat if we have eating speed of 2 or 1. So okay, for some reason I'm not able to select the color, so let me just go here. Yeah, so now what we do is basically, we have our L pointer here, uh, our space, right? So reduce, this thing wipes out because those cannot be our answers, so we eliminate it, and our L pointer moves to mid plus 1, since we need to now increase the eating speed. But if you remember, it's still less than 5, right? So we are still checking if our current eating speed, if we can decrease it further so that we can eat all the bananas within the stipulated time. So let me just copy my, okay, sorry. Yeah, so now in our updated next iteration, uh, we will have L here, R here, right? And L plus R by 2. Yeah, so L plus R by 2, which is basically the mint, gives us 4 here. Okay, and now we'll have to check if we can eat all the bananas. So we're eating 4 bananas per hour. I mean, we checked it out before. Let's just do it again. So we have 3, 6, 7, 11. So ours, this will take 1 hour plus 2 hours plus what is this 2 plus this is 3, right? So this is 8. This is now equal to 8. Okay. So 4 is our answer, and yeah, so 4 is our answer. So now, uh, you know, we don't have anywhere to put it. So now mid is over here. So for the next iteration, right? So if now this part is eliminated and this entire part is eliminated. So if we are going to reduce R or increase L, right? So if we reduce R now, it becomes L less than R. Our normal binary search condition becomes false. Okay, or yeah, or L. So L greater than R. Yeah, L less than R. Sorry, I got confused. So L less than R becomes false because once we move this L forward or we move R backwards, so we basically come out of the loop and end this particular uh, algorithm or a binary search algorithm. So in that case, we just return our answer, which is the minimum, and it's 8. So we keep track of this. So the last thing is like, how do you calculate if we have the exact number of bananas in the pile, right? So that's the if you have anything left, right, right. So what do we do about that? So in that case, like when I showed you the first example, right? Yeah. So here, if k is equal to 4, so basically 6 mod 6 mod 4 will be equal will not be equal to 0. It will be equal to 2, right? So we basically add. Okay. Okay. Yeah. So 6 mod 4 will be equal to 2, and yeah. So essentially, this would be the number of hours that we would need to complete 6 bananas. So instead, if we have like eight uh, 8 mod 4, that will be equal to 0. So that would flatly mean that we need uh, 2 hours to have 8 bananas. And yeah, that's the whole logic. Let's just go to the code, right? I think I made you confused here. I'll show you the code itself. Yeah. So basically, this is what I told you. L comma R, we keep L as 1. This is the eating speed, and R is the max of piles. And while L less than R, we calculate the mid, and then we do this, right? So we're going to check if Coco can eat all the bananas within uh, within our eating speed rate, which is mentioned as H here. So we initialize the number of hours to 0, and for every element in the pile, like we diagram the code, so we add uh, x mod the given r, right? So basically here, if you have 3, 6, 7, 11, so we would be adding uh, 3, then divided by the given r, which is, I mean, it can be 4. So we add it to the actual number of hours. So 3 divided by 4 is 1. And if there are still some bananas left after eating, the mid amount of bananas per hour, then we basically do 3 mod 4. If it's not equal to 0, then whatever reminder we get, we add 1 hour to it. So in this case, it's kind of common sense that the uh, the number of bananas when we do the remainder will always be less than the rate hedge, so we can safely add one to it. So, I mean, apologies if I was kind of mentioning this two forward slashes as modulus, but it's actually division. Uh, that's somewhere I got confused, and I make this video so that I I go through the raw process for you to understand, and I don't really by heart the entire algorithm or the code. So here, right? So if you do uh, if you do a if we do a 6 divided by 4, the flow division, we get 1. Okay, so and after that we still have like 2 left, right? So two the number of bananas left is 2. So we just add 1 plus 1, that is equal to 2, because these 2 bananas need an additional 1 hour to be eaten, so it becomes 2. Okay, so now it's much clearer for me, I think, hopefully for you as well. So in the end, right, so once you've gone through all the piles, we actually check if the action number of hours is less than our limit, which is h in this case. uh, so yeah, this is the entire code, and I mean it's a bit tricky, but if you get a hang of it, there are a lot of questions like this that you can solve. It comes up in your OS and interviews quite frequently, so the time complexity is quite quite straightforward. That's uh, basically a login, and because now the space complexity right here, right? So if you go, you can actually see that we're not doing anything, right? So uh, we don't need any space except for, I mean, the variables that we're using. There's no space, and since we're using 2 pointers and not the recursive binary search stack, we don't need any space. So here we have one. Okay, so yeah, it's a bit of a long video, and I might have confused you and me as well. But if you rewatch this again, I'm pretty sure you would learn a lot from this. So thanks for watching. I'll see you in the next one.